Hi everyone. So I'm glad to be here. My name is Hoberdan Silva. I work for British American Tobacco in Brazil for 28 years. Currently, I'm responsible for a new area that we create for digital transformation in the organization. So the idea is to remove all work in the shop floor that use paper, that are paper-based, to extract maximum from our automation that we built through the years, and to bring some new technologies, like something that we're going to present to you guys now. So a bit about BAT Brazil, specifically on the manufacturing. We have a bit over 1,000 employees. We have been running 24/7 since 1978. And we have plenty of certifications. And one of the last ones we got was carbon neutral. And a part of my presentation is related to that specifically. So through the years, since the 90s, when I arrived at BAT, we used to collect data using paper forms and then type this manually on computers to consolidate data so far. And we keep evolving, using PDAs, and then by the early 2000s, we start data collection automatically from all the equipments on the factory. And as we advance on data collection, we also advance on our data analytics, all right? And in the past 5-6 years, we have this challenge to be carbon neutral, and we want to, all the big stuff we already have been done in order to reduce fuel consumption in the site. So we start looking into details, and we got into this model that, okay, we understand that our equipments, they have some intrinsic, let's say, instabilities by the traditional control that those equipments have, especially PID, closed loop controls. We have also our operational interventions from the guys on the shop floor trying to correct the mistakes from the equipment. And of course, we also have manual target definition, everything based on the experience, on the knowledge of the people that is running the factory, right? So looking at a specific area where we do conditioning on tobacco, so where we got like dry tobacco, and we need to optimize that, and also our boilers, all right? So what we did in 2021, we look at the market to find opportunities to improve fuel consumption on our boilers. And that's when we brought Amer company to work together with us. So they replaced our traditional PID, closed loop controls, by some neural fuzzy algorithms using some edge computing on the electric panels of those boilers, all right? And we are able to achieve 4% of fuel consumption reduction. Looking at it, okay, what else can we do with this approach? So we deployed the same technology on a dryer that we had for the tobacco process, and the results were okay as well, was good for us. But at this point, we find out something that was not the original objective of the project, which was I got a feedback from the operational team. We were like in a meeting one day, and the guy's okay. Oh, and by the way, I'm running this dryer now with this new girl that have like 3 months on the company, and I was like, whoa, just 3 months? Because usually you on that specific equipment, you want your most experienced employee because it defines the final quality of the tobacco that goes to the cigarette production, all right? So usually you don't address someone to that location with less than 1-2 years of BAT experience, So that gave us an idea, okay, hold on, so if I can reduce the amount of time to prepare someone to run the machine, because now the process is more stable, so the person don't need to have all that experience to, look at the graphs and, oh, it's getting out of control, let's do a correction. That is not necessary so much anymore. Then okay, let's look some different places we can use that. So looking at this specific area, the process end to end, we decide to deploy this in 4 different equipments, the more critical ones that are responsible for conditioning and drying of the process. And for all of those, we achieve the same results. So it's easier to operate the equipment now. We still need the operators, of course. They do a lot of other stuff than just changing targets on the machines. But it makes their life quite easier, all right? And we are looking into the future. Okay, so looking now, what else can we do? Currently, we are looking at this final stage of this process where I have like the transition between this area that I'm processing tobacco to the area that I produce my final product, all right? And here there are 2 key decision-making process happening. So I have a storage area where I have this operator that keep looking at the results on the final product. Okay, what was the results yesterday? What is my the weather prediction for today, for tomorrow? And based on this, in his experience, he decides, okay, guys, you should produce the tobacco with this amount of moisture. And this all based on his experience and his gut feelings, all right? So we want to replace that decision-making now by some algorithm as well. The preliminary tests that we have been doing, we are achieving more than 90% of accuracy with this new decision-making. And the second decision that is made in this area by this same person, because I have this warehouse, all right? And this guy is not perfect. He may ask people to produce with, like, let's say, with 14% of moisture, but he knows that he may be wrong, all right? So what he does is, oh, it's not working? Hello? Yeah, it's back. Sorry. So what he does is, okay, I'll ask for 14, 14.1, and 14.2 because he's controlling the storage, right? So he asks for different targets because he knows if he does a mistake, he still have some leverage to correct this. So he decides also what he's going to send to production, actually. Because I'll store around 1 day of a semi-finished good in this area, and he can choose around the day what he's going to send to production. So this decision we also want to replace, all right? And I could keep telling you guys from a lot of other stuff we are doing, but I would like to bring this case because I think it's a good one. So some of the lessons learned from this experience is strong automation and data collection foundation is key. So we invested since the early 2000 in a lot of integration between the equipments and a lot of data collection, and now we are harnessing the fruits of it. You need to ensure that you have a health maintenance and operational process because people sometimes want to use technology to solve a process problem. So if you try that, you will fail. First, you need to make the process work properly, then you deploy technology upon it, on top of it. You should define what is your success criteria in advance. You need deep knowledge on the automation you have and the process you have to deploy this as well. You need to focus on simplifying the life of the user. So like when the guys noted that he didn't need to keep looking at the screen the whole time to make sure everything was okay, he was happy, and then things was easier for us. You should not focus on headcount reduction from the start. I mean, of course, this will come as a final result over the years, all right? But if you start the project with this, like in mind, okay, in the next 3 months, 6 months, I'm going to reduce 10 employees, That's a lot of pressure, and it's hard to hide that from everyone. And you face a lot of resistance from the operators because they will, okay, you're trying to take my job, so you don't want that aspect, all right? It's a long-term game, so we start in 2021, like it was 1 year to have one success case, then we move on to the next one. We didn't like to rush things. And one interesting point is like algorithms also demand maintenance, all right? Like what we learned through in the past 3 years is like if you have some change in your process or a change in the raw material, you may need to do some maintenance on the algorithms as well. They do have some level of autonomy, but there are limits for that. And that's it. And now Renato will explain to you guys how it all works.
So thank you. I'll try to use this time here to get a little bit of technical details of the technology we brought to British American Tobacco. So basically, what we do is to transform any edge device or any small computer into an edge device to communicate to the facility. And to make that work, we embed it with the UAO runtime using 4DX. So we did a nice contribution last year. We did a plugin where now you are able to use UAO runtime inside 4DX. So we are calling this universal automation-oriented device. So any device that you embed with the UAO runtime becomes an universal automation-oriented device. And then we have a set of drivers to communicate to any brand of PLC. So the PLC, the DCS system become like infrastructure to us. And once we communicate this edge device with these PLCs, then we have a set of function blocks, for example, advanced process control. And I show you here 3 kinds of function blocks that we use a lot. The MFAC, it's an online learning control. So this controller is really good for poor system information or some industrial process where you have some natural variability, such as boilers running with biomass as fuel, where you cannot control pretty much the quality of the biomass. So this real-time machine learning control keeps looking at the result of the controller and tuning it back. We have the classic model predictive control. We have real-time optimizations, reconciliation systems, all in function blocks. Okay. So looking directly to the facility, this could represent the full facility. And once we start deploying controls, optimization, and other systems to the facility, then we start having what we say a software-defined facility, because the decisions are coming back from software. So the software is deciding what to do. Of course, we bring this experience, this business experience from the client. We stay some time watching the processes, talking to people. So you can divide this specific facility into utilities, into primary sector, and product storage supply chain and manufacturing sector. So once you have all the process with some kind of decision making, so we are calling the advanced process control or real-time optimization as a decision making tool. Then you can close the loops upper and upper. Probably one day you're gonna have a higher loop which manages all facilities of the company around the world. Okay, probably we're gonna reach this point one day, and all deployed with the 61499 with the UAO runtime, with industrial edge devices. And at the end, we have also the manufacturing sector, where we have the opportunity to use a little bit of generative AI. Okay, so this is an overview of the architecture. We are dealing with the client and the set of products. So we have from data collection to industrial data analytics to advanced process control, which we call the first decision-making tools. The IoT manager, so if you have some kind of sensors running wireless, then you can manage into the platform that we have. We have digital twins, and we have a recommendation system. This recommendation system, in practice, it is like the digital lean manufacturing. So the client has a lot of experience on lean manufacturing, and through generative AI, through large models, we can take a generic model. Through this generic model, you can feed it with the data from the manufacturing. And once you feed it with the data of the manufacturing, you can bring it to an inference model into an edge device with an NVIDIA. So this is one that we have there from SRock. And this will bring a lot of cost reduction over the decisions with generative AI. So if we can say something about the future of the industrial edge, we are working to make this run. We already have the generative AI model running, but now our job is to bring this to this industrial edge device for this kind of inference system. So this is what we see as a future, because it's really expensive to train the models over the cloud. Doesn't matter if you are doing Oracle, Microsoft, AWS, it's always expensive. And if we can bring this model to this edge device, what we are doing right now, it will significantly reduce the cost. Okay, so thank you.